Lovely.
Okay, so June's going to stream the videos afterwards, but I'll stream the slides first. So everyone can hop into my stream. Everyone's able to see this well? It's in full screen and everything?
Yeah.
Okay, perfect. Hello, my name is Connor Walsh. Welcome to the Introduction to the Go Programming Language Workshop. So first, you might want some backstory on why Go was even made. So the goals of the Go project were to eliminate the slowness and clumsiness of software development at Google, and thereby to make the process more productive and scalable. So you'll notice that this programming language was made at Google by 2 Google employees at the time who are now ex-Google employees and do this full-time instead. The language was designed by and for people who write and read and debug and maintain large software systems. In essence, Go was not made to be a revolutionary language with crazy features. It was made to be easy to learn and to use for software engineers. So why would you want to learn Go? Go has built-in, very simple to use concurrency, which is having multiple different processes run at the same time. Well, not exactly at the same time, that would be parallelism, but in alternating on multi-threading. It has a great standard library, so for all of your printing and all of your math and sorting libraries, they're all built in. Go is very fast. It doesn't need a virtual machine to run, making it similarly as fast as other low-level languages like C and C++, and it's very easy to learn. So one of the biggest differences in Go is how variables are declared. So in most other languages, you would use like variable and then the type and then the name of the variable equals to the value. In Go, you do the variable, then the name of the variable, then its type. So you would say var x int instead of var int x. It's very it's a very small thing, but it does take some time to get used to when you're actually writing code. I found myself doing it like just making that mistake every single time for a while. So in order to use the print, you need to import the FMT package, which I believe is format, I hope. And you'd have to use the fmt.println. So you're also able to have Go infer a variable's type by using the := operator. So that basically makes everything in the previous slide redundant, because you can just do this instead. And Go also has pointers like C and C++, but was written to be memory safe, unlike C and C++, meaning that you won't have to worry about any dangling pointers or other memory-related issues. Okay, and so June, you can play the first video that I sent. So everyone can hop over to June's stream. We can watch this together.
Go is a really popular language at the moment, and for good reason. It's a really great language to learn. I'm going to give you an overview of the language, and by the end of the video you'll hopefully have the skills that you need to write simple Go programs. If you go to golang.org, you'll find a link to be able to download and install Go. If you're on a Mac, you can use brew install Go if you find that easier. Once you've done that, you'll have the Go command line tools available. When it comes to creating a Go project, you might find it a little different to what you're used to in other languages.
Gotta share an application to have sound share.
The idea in Go is that all of your...
This is the exact issue I was having earlier.
Well, let's hope it doesn't persist.
Go is a really popular language at the moment, and for good reason. It's a really great language to learn. I'm going to give you an overview of the language, and by the end of the video you'll hopefully have the skills that you need to write simple Go programs. If you go to golang.org, you'll find a link to be able to download and install Go. If you're on a Mac, you can use brew install Go if you find that easier. Once you've done that, you'll have the Go command line tools available. When it comes to creating a Go project, you might find it a little different to what you're used to in other languages. The idea in Go is that all of your projects live in the same place, and this place is called your workspace. By default, this is a folder called Go in your home directory, and you can see this if you type go env gopath. So I'm going to actually create this folder. This is our workspace. Inside here we need another folder called src. And this is where all of our source code is going to go. So now inside of src, you can create a folder for each of your projects. Let's make our first Go file. You'll often see them being called main.go, but it can actually be called anything. The first line in a Go file needs to be the name of the package. Every project, at least if you want to be able to execute it, needs to have a package called main. The next section is the imports. This is where you can import different packages. There are loads of useful packages in the standard library. A common one is FMT, which has functions related to input and output. So open brackets, and then you can list out all of the packages that you want to import. Note there are no commas in this list. We'll just use FMT for now. Next, let's look at functions. You use the func keyword followed by the name of the function, and the first one you'll want is a function called main. It takes no arguments and it doesn't return anything. But this is where the program starts, a function called main inside of the package called main. This will output hello world to the terminal. To run this, you can use go run followed by the name of the file. If you want to compile the code into an executable, then you can use go build in the program's directory. So this time, it doesn't run our code, there's no output here in the terminal, but what it has created is this binary file here. This is an executable. In Windows, it's going to be a .exe file, and we can run that in the terminal. Alternatively, you can use go install. This is going to do something very similar, except the executable is put in this bin folder. It sits in our workspace next to the source folder, and if this program had external dependencies, so if we'd imported something from outside of the standard library, it would compile and cache those dependencies into a package folder. Let's go back to our Go file and look at variables. To declare a variable, you use the var keyword followed by the name of the variable and then the type. So I'll make an int, I can output this. If we don't provide an initial value, then the 0 value for the type will be used. Every type has a 0 value. For integers, the 0 value is literally just 0. For strings, for example, the 0 value is the empty string. I could later assign something to this variable, or I could do it at the same time as declaring it. So I could do this again, and then add the two integers together. So we get 12. When we give variables an initial value like we're doing here, there's a shorthand syntax that we can use. Drop the var, add a colon and an equals, and then the value. And we can omit the type because Go can infer it. So this is the same as what we had before. If I do this to all of them, you can see we get the same result, but this is a bit neater to read. Go has if statements. They allow you to execute a block of code if a condition is true. Note that there are no brackets around the condition. There's also else if and else. Let's look at arrays. An array holds multiple elements of the same type, but the number of elements that an array holds is fixed. It has a specific length. For example, we could create an array that holds 5 ints. If we output this, we can see that it does hold 5 ints. All of the elements will be initialized with their type's 0 value. Again, in the case of ints, this is the number 0. We can use square brackets to index the array, so we could set element to position 2 to be 7. Arrays are 0 indexed, so the first element is at position 0. If you want to be able to initialize the contents of an array more easily, we can use the shorthand syntax again, so drop the var, use a colon and an equals, and at the end of the line, open curly brackets, and then you can list out your values here. Now you might be thinking, arrays with a fixed length sound inconvenient. Well, they are. If I wanted to add a 6th element to this array, I can't, because the length of the array is part of the array's type. To overcome this, you can use slices. Slices are an abstraction over the top of arrays to make them easier to work with, namely, they don't have a fixed number of elements. So if we wanted to create a slice of ints instead of an array of ints, we simply remove the element count and leave an empty set of square brackets. So now this is a slice of ints. So why is this useful? Well, now we can use the built-in append function to add something new to the end of the slice. Append doesn't modify the original slice, it returns a new one. Slices are backed by arrays, so here Go will be creating a new array in the background and copying stuff across, but when you use slices, you don't have to worry about it. It all happens behind the scenes. Maps are really useful. They hold key value pairs. They're like dictionaries in Python or associative arrays in PHP. The type definition for a map is the word map, and in square brackets, the type of the keys, followed by the type of the values in the map. And to create a map, you use the built-in make function and give it this type. We can set key value pairs using square brackets. It's similar to indexing arrays. You can use the same syntax to get the value for a particular key. And you can use the delete function to remove something from the map. So square is now gone. Next, loops. The only type of loop in Go is the for loop. We declare and initialize a variable using the shorthand syntax we saw a couple of minutes ago. This is the counter, then we set the stopping condition, so loop while I is less than 5, for example, and then after another semicolon, you can increment the counter or decrement it or do whatever you want at the end of each iteration. So this is going to go through the loop 5 times and print out the number, the value of I in each iteration. So it starts at 0 and it goes up to 4, and as soon as it gets to 5, it's not less than 5 anymore, so it stops iterating. The for loop also doubles as a while loop, so if you delete the variable declaration from the beginning and the increment at the end, you've got a while loop. So this will do the same as before. Another thing you can do with the loop is iterate over each element in an array or a slice by using range. We get the index and the value out of doing range of an array. Println has a feature where you can pass multiple arguments to it and it'll output all of them separated by spaces. You can do the same thing with a map, but you'll get the key instead of the index. So far we've had everything in the main function, but we could easily create a new function. If you want to accept arguments, you just need to give them a name and a type. And if you want to return value, then you need to give the type of that after the brackets. So this is going to take 2 ints and return a different int. So we could do something really simple like this, and then call it up here. In Go, functions can have multiple return values. So if I made a square root function, which takes a float 64, it can return another float 64, and it can also return an error. These are all built-in types. Since the square roots of negative numbers are complex numbers, we could limit this function to positive inputs only, returning an error if x is less than 0. So we want to return 2 values. The first one is the float 64. We're not doing the calculation, so I'll just return 0. And then we can use the new function in the errors package, if I import that, to create an error. Otherwise, we can do the square root. There's actually a square root function in the math package, so I'll just defer to that. We still need to return 2 values though, and in this situation we don't want to return an error, so I'll just return nil instead of an error. So now when we call our square root function, we get 2 values, we get the result and we get an error. If the error is not nil, then that means something went wrong, so let's just output that. Otherwise, output the result. So it does the square root of a positive number. If we were to make this negative, then it's going to return an error and we'll get this line executing instead. So that's how functions with multiple return values work. It's really useful to be able to return errors like this because Go doesn't have exceptions if you're used to working with those in other languages. A struct is a collection of fields, so you can group things together to create a more logical type. To create a struct type, you want to do this outside of a function. Use the word type followed by the name, so this can be anything you want, and then the word struct. Inside curly brackets, you can list out the fields that you want the struct to have. Each field needs to have a name and a type. So I'm going to make this one a string, and I'm going to make this one an int. It could be anything, it could be another struct. So that's the type. To create a struct of that type, you want to use the name of it, and then just like when you initialize an array or a slice, you can use curly brackets to set the fields. So first I'd set the field called name, I use a colon and then the value. And if I output this, you will see it's created a struct. If you want to get a specific field out of the struct, then you can use dot notation to do that. So this time it'll just output 23. The last thing I want to talk about is pointers. If I have a variable, as we've seen, it's really easy to output that. But we can also get the memory address of the variable by using an ampersand. So this gives us a pointer to I. Now if I had a function which incremented a variable, and we called it like this. This is going to be useless and not actually do anything because I is copied by value, so the increment function gets a copy of I. It increments that, but then since we're not returning anything, that copy is just discarded and the original variable is not modified. If, however, we pass a pointer to the variable, then the function is going to be able to look at the value at that memory reference and modify the original version. So we can accept a pointer by prefixing the type with an asterisk. We can send the pointer by using ampersand. And what we need to do here is dereference the pointer, so we use another asterisk here. Without that, this is going to be incrementing the memory address, but that's useless. We want to see what's at that memory address, using the asterisk, dereference it, and then increment that value. So now this actually does modify the original I variable. Very quick introduction to pointers. I've glossed over a lot of details here. If you're unfamiliar with pointers, it's definitely worth taking the time to read up on them properly. But I hope this has been a good introduction to the language. We've learned about functions, variables, if statements, arrays, slices, maps, loops, errors, and pointers. It should be enough to get started. Leave a comment if you do have any questions. If you're interested in a career in software development.
Yeah, that's good for that video. So before we get into the next one, I would like to just basically say that the next video is not just good for learning Go, but it's also good to understand the concept of concurrency, which is, I mean, not limited to just the Golang. You can use it in many other languages, and you probably will be using concurrency if you're a software developer. So now we can play the next video. June.
In the first video, Learn Go in 12 minutes, we had a very quick look at the main features of the language, so you could get going straight away. One thing I didn't talk about though was the support for concurrency that Go has. This is a really big part of Go, it's a big selling point, and a reason why a lot of people choose the language, so I thought it deserved its own video. It's worth understanding that concurrency is not quite the same as parallelism. To run things in parallel means to run two things at exactly the same time. This is what happens on a multi-core processor. You have one core doing one thing and another core doing a different thing, both simultaneously. Typically though, the lines of code that make up a program have to run in the right order, which makes it hard to parallelize and execute two lines at the same time. So concurrency is about breaking up a program into independently executing tasks that could potentially run at the same time and still getting the right result at the end. So a concurrent program is one that can be parallelized. We're not going to concern ourselves with what is happening at the CPU level and whether something is running on multiple cores or not. The Go runtime and the operating system will take care of it for us. We can concentrate on the structure of our program and using the tools that Go gives us to make our code concurrent. So I've got a text editor. I'm going to write a really simple function called count. It's going to take a string as an argument, and in an infinite for loop that starts at 1 and just loops forever counting up, I'm going to output the number that we're at and the string that we passed in. And then I'm just going to sleep for half a second. And I can count sheep, and then I'll make a call to count fish afterwards. So this is a synchronous program, there's no concurrency here. It's going to execute the count function, and it's going to wait for it to finish before moving on to the next line. But the count function never finishes, so it's just going to count sheep forever and never get to the fish. So I'll just do that until I kill it. If, however, we call the function with the word go in front of it, it won't wait for it to finish before moving on to the next line. It'll say, go and run this function in the background, and then continue to the next line immediately. And this creates what is called a go routine, and that go routine will run concurrently. So we now actually have two go routines. The main function with the main execution path of the program is a go routine, and now this new one that we've created explicitly. So these will both run side by side, and we see now it counts fish and it counts sheep. Go routines are very efficient. It's okay to make tens, hundreds, even thousands of Go routines, but bear in mind that you can't make a program infinitely fast by adding more and more concurrent Go routines, because ultimately you are constrained by how many cores that your CPU has. I'm going to make one tiny change to this program and run both count functions as Go routines. Now you might expect this to do exactly the same as before, and you'd be almost right, but we get a very different result. We don't get anything. So what has happened? Well, in Go, when the main Go routine finishes, the program exits, regardless of what any other Go routines might be doing. Previously, the main Go routine never finished because it would have this infinite for loop in it. But now we've pushed that loop into its own Go routine, so the main function will continue immediately to the next line. But there are no more lines of code, so it's done and the program terminates. And the Go routines that we've created ourselves haven't had time to do anything. If we were to sleep for 2 seconds here, you'll see it now outputs for 2 seconds and then it terminates. You'll often see people add a call to fmt.scanline at the end of the main function to fix this problem. And this will stop the main function from immediately terminating because it'll wait. This is a blocking call. It'll wait for user input. So this gives our Go routines time to execute, and it's going to keep doing this until I press enter. And at that point, it'll move on and the main function will finish and the program will exit again. In reality though, this is not a very useful solution because it does require manual user input. What we can do instead is use a wait group. I'm going to import the sync package from the standard library. And let's just alter our program so we have one call to count, and let's just count up to 5. To use a wait group, I'm first going to create one. And it's nothing scary, it's just a counter. And I'm going to increment it by 1 to say that I have one Go routine to wait for. And it doesn't do any magic here, it's up to me to increment it. The next step is to decrement the counter when the Go routine finishes. So after this for loop, I want to decrement the counter. Now I could pass a pointer to the wait group, to the count function, but I don't think it's really the responsibility of count to deal with this. So instead, I'm going to wrap the call to count in an anonymous function. This syntax creates a function and then immediately invokes it. So this will still run as a Go routine, and inside here I'm going to call count again. And then afterwards I'm going to call wg.done. Since we've created this function inline, we have access to that wg variable, which is convenient, and done literally just decrements the counter by 1. So all we have so far is a counter of how many Go routines are running. The useful bit now is to call wait at the end of the main function. This will block until the counter is 0, so if any Go routines haven't finished, it'll wait. So now it's going to count to 5, count will return, we'll call done, which will decrement the counter, and then this wait will be like, oh, the counter's at 0, and allow the code to continue, and the program terminates. Really easy to use. So that's how to create a Go routine. Really simple, but not massively useful so far. What we need next are channels. A channel is a way for Go routines to communicate with each other. So far, the count function has just been outputting directly to the terminal, but what if we wanted to communicate back to the main Go routine? Well, we can accept a channel as an argument. And it's like a pipe through which you can send a message or receive a message. Channels have a type as well, so this one will be a string channel and will only be able to pass messages that are strings. Any type works though, you can even send channels through channels. So instead of outputting thing to the terminal, I'm going to use this arrow syntax to send the value of thing over the channel. So an arrow pointing into the channel name will send a message. Going to get rid of the wait group stuff now. So a nice simple concurrent call to count. And now we need to pass the channel in. So first we can make one using the make function. Pass that to count, and then we can use an arrow coming out of the channel name to receive a message from the channel. So this is going to receive one message, output sheep once, and then terminate. And it's important to understand that sending and receiving are blocking operations. When you try to receive something, you have to wait for there to be a value there to receive. Similarly, when you're sending a message, it'll wait until a receiver is ready to receive. So we can see it does what we expect, it outputs sheep. And this blocking nature of channels allows us to use them to synchronize Go routines. Imagine you have two independent Go routines. Each line here is a line of code. We don't really care what it is, except down here, we receive on a channel. And over in this Go routine, we send on the channel. When they both execute, sometimes one will stop and start and the other will stop and start. They might be executing different code. They won't stay synchronized at all. But when this Go routine on the left tries to receive on the channel, it'll stop and wait until something is sent. And at some point, the other Go routine will reach the line where it tries to send, and then they'll be able to communicate through this channel. So at this precise moment, they're both at this communication point. So we're communicating and we're synchronizing, which is an important concept. Back to the code. This just receives one message. If we wanted to receive all of them, then we could wrap this in a for loop. So this does what we expect, but then it gets a fatal error. We get deadlock. This is because the count function is finished, but the main function is still waiting to receive on the channel, but nothing else is ever going to send a message on the channel, so it'll be waiting forever. The program will never terminate. Go is able to detect this problem at runtime, not at compile time. It hasn't solved the halting problem, but when it actually happens, it can see that Go routines aren't making any progress. To solve this, we can close the channel. As a sender, if we're finished sending and we don't need the channel anymore, we can close it. If you are the receiver, you shouldn't ever close a channel because you don't know whether the sender is finished or not. If you close the channel prematurely and then the sender tries to send on that closed channel, it'll cause an error, it'll panic. But it's okay for the count function here to close the channel because it knows that it's done and it's not going to use it anymore. When we receive on the channel, we can actually receive a second value which tells us whether the channel is still open. If it's not open, if it's being closed, then we can break out of this for loop. So now we don't get the deadlock anymore, and there's actually a slightly nicer way we can do this in Go by iterating over the range of a channel. So this will keep receiving messages and putting the value into this message variable here until the channel is closed. So then we don't need to manually check that it's closed anymore. Exactly the same result, just a bit of syntactic sugar. So we've seen so far that sending to a channel is a blocking operation. To demonstrate the constraints of this, I'm going to do something really simple. I'm going to make a channel of strings. I'm going to send hello across the channel, and then I'm going to try to receive from the channel and output it to the terminal. Naively, we might expect this to work and just output the word hello, but we're actually going to get deadlock again. This is because the send will block until something is ready to receive, but the code never progresses to the receive line because we're blocked at send. To make this work, we'd need to receive in a separate Go routine. Alternatively, we can make a buffered channel by giving a capacity when we make the channel. You can fill up a buffered channel without a corresponding receiver, and it won't block until the channel is full. So with a capacity of 2, this will work and it'll output hello. We can even put 2 things into the channel before having to read anything back out. So we put 2 things in, and then we read them, and nothing blocks here. If we try to send a 3rd time though, the channel's going to be full. So that call will actually block and will get deadlock again. The final construct that Go has is the select statement. If I have 2 Go routines, I'll just create them in line like this. I'm going to make 2 channels, which will send and receive strings. The first Go routine is going to send on the first channel, and it's going to be ready to send every 500 milliseconds. So I'm just going to add a sleep here for half a second. The second Go routine is going to send on the second channel, and it's going to do that every 2 seconds. And of course, to make it do this infinitely, I'm going to wrap each one in a for loop. Back in the main Go routine, I could similarly have an infinite for loop, and I could receive from channel 1, and I could receive from channel 2, and then loop and do that over and over again. But we'll always get one and then the other, and then one and then the other, even though this first Go routine is ready to send much sooner. And this is because we're going to block each time, waiting for the slow one. So every time we try to receive from channel 2, we're going to have to wait 2 seconds. So it's really slowing down this first Go routine. Instead, we could use a select statement, which allows us to receive from whichever channel is ready. So in the case that channel 1 has a message, we can output that. But in the case that channel 2 has a message, sorry, that should be message 1. In the case that channel 2 has a message, then we can output message 2. And then we're just going to loop over this. So this time we see that we're able to receive a lot more quickly from channel 1 because this is only sleeping for half a second, and that select statement will keep picking channel 1 because it's available. Finally, I want to demonstrate a common pattern called worker pools. This is where you have a queue of work to be done and multiple concurrent workers pulling items off the queue. I'm going to write a really simple Fibonacci algorithm. It's going to calculate the nth Fibonacci number and return it. So if n is 0 or 1, then just return n. Otherwise, return the sum of the previous 2 Fibonacci numbers. I'm then going to write a worker which takes 2 channels, one channel of jobs to do, and one channel to send results on. Instead of specifying bidirectional channels, we can actually say that we'll only ever receive from the jobs channel, and we'll only ever send on the results channel. And this just reduces the chance of bugs, because now if we tried to send on the jobs channel, we'd get a compile time error. So jobs is going to be a queue of numbers. And we're going to use the range feature to consume items from this queue. So it's just going to receive on the jobs channel. So we're going to receive n from the channel. We're then going to calculate the nth Fibonacci number and send it on the results channel. In the main function, obviously create the 2 channels. I'm going to make them buffered channels and give them a size of 100. No particular reason why I'm picking 100, it's just a nice round number. I'm then going to create a worker as a concurrent Go routine. Give it the 2 channels that it needs. I'm then going to fill up the jobs channel with 100 numbers. So we're just going to iterate from 0 to 99 and put all of those numbers on this jobs channel. And since it's buffered, we're not going to block. That's going to be fine. Once they're on there, the worker will concurrently start pulling one off at a time and calculating the Fibonacci number and then putting it back onto the results channel. I'm going to close jobs because we're finished putting stuff onto that channel now. We are the sender here, so it's okay to close it. I then expect 100 items to eventually appear on the results channel. So that's going to be the first 100 Fibonacci numbers. So I'm just going to receive each one of those and output it to the terminal. So this works, this is fine. It does the first batch really quickly, and it's going to get progressively slower. It's quite an inefficient algorithm. And if we look in Activity Monitor, it's almost maxing out the CPU. It's very close to 100%, trying its best to calculate each Fibonacci number as the worker pulls one off the jobs queue. So that's cool, but what we can do now is add more workers. So I can just copy this line. So now we have 4 concurrent workers all pulling items off the jobs queue and then all pushing back onto the results queue at the end. And if we look in Activity Monitor now, it's using almost 400% CPU because it's using multiple cores. So the work will get done faster. Like I said at the beginning, I don't want to get too involved with how this works and how much faster it makes things because you don't get a massive amount of control over it. But it is pretty cool to see that we're taking advantage of the multi-core processor. Obviously this version doesn't guarantee that the Fibonacci numbers will come out in order, but that's the gist of how worker pools work. And that is a quick tour of concurrency in Go. Really easy to do. Hopefully it wasn't too difficult to understand. If you're interested in a career in software development or you just want to improve your skills, then you might find it useful to dive further into.
Well, so did everybody think that was an interesting little dive into the language?
Very cool. I liked it.
Yeah, I think Go is a very cool language to know and to have on your resume.
Yeah, it's different. There's a lot of new features and stuff that I didn't even know existed.
Yeah, I've done quite a bit of research in what a lot of people on Reddit think about Go. And there was a thread like 4 years ago that they were saying that they think Go is going to be like replacing C, which obviously did not turn out like that, but it does have its uses.
They have their work cut out for them with Rust.
Yeah.
But I imagine it's going to be Rust versus Go right now for the language replacing C. It seems like Rust is winning at the moment.
Oh, it definitely is.
But I am
That's all I
interested
hear
in all
about.
the concurrent features offered by Go. I think that that's really powerful, and I think that they gave some really good demonstrations. So as we have 20 minutes left before 9, and ideally we should at least have the workshop go until 9. I know you said you had some sample code you wanted to show off, but before that, why don't we see if anyone else wants to talk about any of the things that they thought were really cool about Go, or has any questions about Go they'd like to ask.
So I was like listening in and out, right? Because of the IRS stuff. I find it interesting that there's only a for loop in Go.
Yes.
Why is there no if, while, like that? That's kind of weird to me,
Because you can do everything with a while loop or you can do everything with a for loop that you can do with a while loop. Like you saw in the video, I don't know if you were watching at that point, but he removes the initializer and the increment in it, and just has the one conditional part of the for loop, and then uses the for loop like a while loop. So you can really make a while loop without having to call it a while loop. All the functionality is there.
I just found that kind of weird because every single other language, has that and then goes like, you know what? Screw all that. Let's make our own rules.
Yeah, I think their philosophy was to make it like as easy to learn as possible. So probably trying to eliminate things that they didn't need to have two of. I get it, but I also get the other way of just like everyone knows what a while loop is, so why not include it? It's an interesting
And I don't you said like this was made by, or the video said this was made by people who worked in Google
yeah.
and like quit their jobs full time, whatever.
Yeah.
Damn, working at Google sets you up for the future apparently.
Yeah, I feel like every time I hear like about some Google employee, it's always about how like they got their job at Google and then left Google and did something cool.
Well, I mean, yeah, that's how a majority of people like make their stories, you know what I mean? Like
Yeah.
singers and whatnot. Every single group, like One Direction, for example. We're getting off topic, but for One Direction, for example, like Woody, once they broke up, and the singer now, he's like 4 times as famous.
Yeah. One Direction and Go programming. They're like the same thing.
Shut up, Matt. I don't know what to tell you. As a One
No, I think One Direction is more famous than any of the other members combined.
Yeah. Like that's just the example that came to my mind though.
As in like One Direction was way more famous now back then than any of the members like now. I don't know.
We should create a new group called Bidirection and then put linked list in parentheses afterwards. Bidirectional linked list.
Honestly, I think it'd be really cool, right? If like I don't know, maybe 5 or 10 years down the line, right? We actually like this is kind of gets kind of sound like a not hypocritical, but everyone wants to do this. It's like if we can create like an idea and then like make that idea into a company.
As the UAlbany IEEE group.
Yeah, something like that. And the story would be, oh, we met in a club, and now look where we're at.
And now we're millionaires.
Yeah, right. I mean, like, it would work. I could be the not the marketing manager, but I can be the people the person that goes around talking to everybody. I am my way with people. Yeah, that should be fun.
Okay.
You got the $1 million idea?
Actually, I do, but hush hush.
He just told you, dude. One Direction.
Bidirectional linked lists.
Are we gonna get some insight on this $1 million idea?
No.
Well, then I don't see how we can work as a company.
See, how are we gonna make the company?
Okay.
All right. Let us move on to your examples, Connor. Unless
Sure.
anyone has any actual questions about Go.
It's not necessarily like anything groundbreaking. It's just like your typical like loops and stuff. Pretty much everything that was in the video. But we can tweak it around. I can share screens and we can try to write something.
When did Go come out?
I think 2016.
2016.
Golang release date. 2009.
Oh.
Okay. Pretty old.
Because I was gonna say like if this is like the replacement for C or C++, you know.
Yeah.
Eh.
Okay. Here we go. Everyone should be able to see this, right? Okay, so I pretty much just took most of this this from the documentation as code to run. So this was a very basic Go routine like sample code. So we're gonna see. I guess we can start with the original one. So it's just your very standard code here. Here, so I think it's go run demo.go. Yes, I don't know why that took so long. Okay, yeah. So basically using the colon equals operator to set it as shown in the video, and then just a very standard this right here would basically be considered a while loop, as you were saying, Brian, because all of the incrementation is here.
Yeah.
So that would basically just be your standard while loop. This would be your standard for loop, because the incrementation's up here. And then this would just be, this is just a print. Why is this even in a for loop? Okay. Oh, I guess it's just showing off that the language has the break feature. I guess so.
Does this also show that it has infinite loop capabilities by not putting a condition? Would that for loop run forever if you didn't have that break there?
Let's find out. Yes.
Oh, very cool. So you can do infinite loops with no conditions on the for loop.
Perfect. Put that back. So yeah, I mean it's just basic for loop in Go. Let's see if we can tweak around the Go routine demo that they have on their website. So bear in mind, I didn't write any of this. So we have a function up here that just is pass a string, just like in the video. So I believe this will print. So this will print out direct 012 going go routine 012. So let's trace this. So we start here with direct. Okay, so it runs direct, not as a go routine. It just runs it regularly. And then after direct finishes in entirety, it runs go routine as a go routine, which gets run. Where is it called? So it calls going here after. So it sleeps. Yeah, I think this is exactly just like the demo in the video, where so it calls going first, and then all of go routine would get printed out after. If I were to put this after, what would change? Okay, so going would be printed after. Okay, well, interesting. So I don't really know what else to demo in terms of learning a language. So if anybody has any questions about the language itself, then I would be more than happy to try to answer for you.
I demand that we do a live coding session of Fizzbuzz right now.
Fizzbuzz, okay. Should I make a new file?
Let's go. Yeah, do it.
Okay. What do you need? Package main. I'm just gonna copy this. Save. Fizzbuzz.go. The extension is .go, so it's really cool. And then it's func main. That should be good, right? Yep. Oh. I pressed Control S to save it, and it deleted all the imports. Super interesting. Okay.
That is interesting.
I hope that's just a VS Code thing and not like a Go language thing. All right. So, do I know how to do input? Oh, I guess we'll just do a for loop. So it's for. We'll do I colon equals 0 semicolon. It's weird with no. We'll do I is less than 30. And then I plus plus. Did I do that correctly? It looks like it.
Seems like it, yes.
Maybe it's just because there's nothing in there.
What happens if you click on the error or hover the error? What does it say?
I think it's good.
Okay.
Here, let's test this out real quick. I just want to make sure. Go run Fizzbuzz. Should just print loop 30 times. Yeah. Okay. All right. All good there. All right. So then we'll do the basics of Fizzbuzz is you check both first, right? I would hope. I think I'm correct.
I believe so.
If I mod Fizzbuzz.
What do they normally do? 2 and 3, or is it 3 and 5? I always forget.
I think it's 3 and 5.
It's 3 and 5.
Okay.
And I'm literally struggling to find the ampersand on my keyboard. And I 5. Oh, wait. I think that's correct syntax, right? If I need to put a bracket, that's what it is, like that. Okay, then we can do fmt dot println. It's Fizzbuzz for both, right? Okay. Oh wait, there's no else, right? And I think I'm just good to do. Oh wait, yeah. A lot of code reuse here. I'm just gonna go with Fizz for 3 and Buzz for 5. I think that would be correct. Okay, I wanna say that should work. I don't think it did.
Why did you put a break in there?
Oh, I was thinking there's no else, right?
Right.
But no, I think we're.
But then you also want to print out the regular numbers, right?
Do you want to in Fizzbuzz?
I don't think you do. I don't know.
Yeah, you would need an else, so I don't know. What do you do without the else?
That's what I'm trying to remember.
That's what you use the break for.
Yeah, I was thinking maybe if you just stop, if it's both, rather than have them both run, just break after.
Am I crazy, or does Go actually have else?
Does it?
It should, right?
You're probably crazy.
I'm pretty sure it does.
You're probably crazy. Let's be real.
I have found an example of a Go program that uses if else, so I would like to assume that it does have it.
Okay, so then it does, and that makes my life much easier.
Does Go have like a continue?
Yeah, it does. It does.
James, what's the format?
I'm looking right now on Google.
It's literally just else and else if.
Why
It
is
should
it?
be.
Why is it? Concurrent?
Where would I leave? I think I would have to. I'm looking.
Should it be one word? Do you?
I'm
Can you
seeing
hover over
2
it?
words. I think try bringing it back onto the same line as
Yeah.
the brace.
I
They might
complained last time
force
about that.
same
Yes.
This
line
must be just
braces.
a-
Oh,
That's crazy.
that's weird. They should not be enforcing same line braces.
Yeah.
That is not a good
That-
feature.
That might be a editor thing, though. You know.
Wait, Connor, undo it and then go to your problems tab. Put else if on its own line and then go to the problems tab on the thing. Expected same. Wow, it's like a Go thing.
Oh,
Wow.
That's
Interesting.
Why would you have braces in your language if you're gonna force lines like
Yeah.
that?
that's crazy, actually.
That's very interesting. I
Worst
didn't.
of all
very
worlds.
All
That's
right, so
dumb.
I'm gonna do.
And then for Fizzbuzz, I think you want to print out the number too.
Yeah, I'll do print out I for all of them.
Oh no, not for those, just for the other numbers. So Fizzbuzz.
Oh,
Oh,
that's right.
1,
Yeah.
2.
The final case, the else case.
Yeah.
You print out the actual number.
Oh, they do?
Yeah.
Yeah. It's,
Oh, really?
It's a
Oh.
game actually that
Mm.
like kids play.
Oh, damn.
Like
That's
you say like
technical.
1, and the next person says 2, and then you have to remember to say.
Oh, that
Okay,
sounds like
okay.
a fun end of the year party activity. We can
Oh,
all
yeah.
hop in the Discord call and play Fizzbuzz, but I'll have the
Right.
Fizzbuzz program up to assist me.
So we have a issue with. Well, I guess 0 technically falls, right? No.
Maybe you need another case for it then. Oh, just
think
start
you
from
could start
1.
with the
You're supposed to
one.
start
Yeah.
from 1.
Yeah.
Yeah, start from 1.
But it doesn't. That's you could.
Yeah.
You can say that's correct. It is correct.
Okay, so 1, 2 fizz, 4 buzz fizz.
6, yeah.
But
6 is
yeah,
3.
yeah, that's right. That's right.
Yeah, that's good.
Okay, 7, 8 fizz buzz, 11 fizz,
It's working.
13,
Yeah, it looks
14
good.
fizz buzz.
Beautiful.
All good. We did it.
All right, Fizzbuzz and Go. That's fun. All right, next let's write a 3D game in Go. Import
Okay.
OpenGL.
Okay.
Let's get rolling.
You have 15
Yeah.
minutes, Connor. Go.
I think I could do that in 15 minutes. I would just have to Google search and copy a lot. Almost the
God.
entire.
You're God.
All right. Does anybody else have any questions about Golang? Does anybody want me to slave away and do more coding problems in a language that I'm not entirely fully familiar with?
I want to see like a really good demo of why concurrency is better than normal stuff. And I feel like it has to be there has to be like a good concrete example of why the concurrent paradigm is so important to Go and how it can be used in a way that makes it better than other languages. But I have no idea what it would be.
Yeah, I wouldn't be able to write that.
Don't, like, almost every language has concurrency, don't they?
Yes. But Go is like really explicit about giving you the ability to
makes it very simple to start.
Concurrency simple, yeah.
I mean, I feel like JavaScript is pretty simple.
Well, at least in the example they gave, it was clear that if you have a part of your program that's just going to go on for much longer than you expected, it won't hold up your whole program. Like the other parts get to run.
Yeah.
Right.
And there's cases where that's very important.
I'm on Google right now trying to find out concurrency. I want to say use cases, like uses.
I liked how he clarified that it had not solved the halting problem.
Yeah. Yes.
Imagine if the Go language had solved the halting problem. I sure hope it didn't solve the halting problem. We'd have bigger issues.
It really went under the radar if it did.
Yeah.
Yeah, so I went on Google to try to find out why concurrency is like explicitly useful, and what I got is it's what I like to use. That was someone's defense for that.
Very nice. I mean, when I think of concurrency, I like to think of like the web page loading and everything, how it handles all the async stuff concurrently.
Yeah.
And as well as like games, video games and stuff, you can implement in a single thread, but have it do all of the game logic concurrently in two different things. Like, it's pretty cool. I think that there's definitely some good applications of it.
Well, yeah. Seeing as Go is a very popular language now. Oh, I forgot to put the statistic in my slides. I saw a graph somewhere of like most looked for like languages on resumes, and Go was like very high up. I think it was number 1.
Most looked for?
It was most like.
Was this put out by Google?
Let me try to find it.
Just kidding.
Most...
I wouldn't be surprised if it was.
Propaganda.
Yeah, I mean, there are definitely way more popular languages. Maybe it was like of the new languages, of the non-C, Java, all those. Who knows? There's a lot of fake news. I could have been lied to.
Go is definitely a good backend tool these days.
Yes, that's what it's mostly used for in like actual in the field.
Yeah.
All right. Well, does anybody have anything else they would like to add or ask?
I just have like a random question for James. Does C++ have like a backend like framework like other languages?
It's compiled down to assembly code. I mean, it's complicated. It's not like Go where it has like the manager, the JVM, where the Java virtual machine is managing it, right?
Mm-hmm.
It's explicitly compiled down to assembly that you could make the argument that there is a little bit of stuff going on. There was originally supposed to be a C++ garbage collector that was still is in the standard. Actually, no, they just took it out. It was implemented in C++ 14. No compiler ever ended up implementing it, but you were supposed to have the option to have an optional garbage collector in C++. And they took it out in, I think it was the 2020 standard. So there's definitely stuff where it's like, C++ does manage stuff behind the scenes, like especially for exceptions and everything. It will inject its own code to do exception handling, but it's not as much as of a real backend as most languages have to them. Like the JVM is like a massive program in of itself, while the C++ backend is more just like code that's inserted in to help your program, if that's a good way to think about it. And of course, there's a lot of stuff that's operating system dependent in C++ code when they compile it, right? So that's one of the big things is the different executables, right? You have to you have your executable target, and the operating system will throw a bunch of its own managing stuff in when you compile a C++.
Interesting.
Yeah, if you want to, you learn a lot about that when you do operating system development and like compiler development. That the operating system is actually what puts in most of the quote unquote back end framework for C++ and C programs.
Yeah, the thing is, the operating system we are taking is fully on Java, and I'm actually confused on like what he's talking about.
Yeah, don't.
Like...
I feel I'm in the operating systems class too. It's not good. It's not. It doesn't give you a real overview of a real operating system. He should have just had us make a real operating system.
Yeah.
It's not that bad to do like a nice hello world operating system, and even just to get like the basics going of doing a simple operating system with like keyboard input and command line wouldn't be that bad. I think he overestimated the difficulty of it. He probably didn't want to jump in on it too soon, but
yeah,
so be it.
It makes more difficult just doing by Java. Actually,
it does.
Anyway, I'm so confused.
why don't we wrap up the Go language workshop, and then June and Josh, I know I said I was going to stay after to discuss the PR. Can we do that next Tuesday instead? I didn't realize I had something right after this.
So next Tuesday?
Yeah, next Tuesday at 8. we'll have a special admin meeting to order all of the stuff with the budget and just get that worked out. And June, you can just stay for like a few seconds and tell us about the shirts.
Did we decide on a shirt?
Yes, technically we decide on one. We might decide to do two and let you pick which one you want, but we're definitely not ordering multiple sizes. We're just going to get a bunch of larges, I think. I'm still not entirely sure. We have to discuss this in officers chat.
Wait, James, we're having admin meeting on May 4th.
No, we're having it the week before, because the May 4th there wouldn't even be a meeting left. There would be one meeting after that.
April 27th?
We're having a meeting April 27th, but we'll have a special meeting next Tuesday on the 20th to discuss purchasing shirts, honor cords, and the PRs that we have to make.
Okay, got it. So 20th, 8 p.m.?
Yeah, 20th, 8 p.m. We'll have a special admin meeting
All right.
for finance.
Yep.
Okay. Well, with that, thank you everyone for coming out to Connor's workshop. I'll go over a bit of what's going on over I'll go over the schedule really quick. So tomorrow we're having side project development night. There's going to be a lot of fun stuff that's going to be shown off. I know a few people have already approached me and told me that they're going to be showing things off, and I'm going to be showing some stuff off as well. And as always, if you have any questions about what libraries you want to use in your side project, or just any ideas that you want to discuss with experienced programmers before you get started on your side project, by all means, show up tomorrow night. Monday night, we're going to be having interview prep as always, coding prep. And again, next Tuesday, we're going to have a finance officers meeting to discuss purchase requests and finance. Then next week on the 21st, Josh is going to be hosting a machine learning workshop, followed by Matt Keelan on the 22nd, who's going to be... Is Matt here? No? I forget what workshop he's hosting. 23rd again, that's going to... It's what?
It's a Discord bot.
No,
it's not him.
Wrong, Matt. That's the week after.
Yeah, whoops.
Yeah, I think the one next week is on software design patterns on the 22nd.
Yeah, that's what it is. James.
And then the 23rd is going to be once again side project development night. Also, this week in related news, tomorrow night is the last meeting to get your attendance to its final numbers for the elections. To vote in the elections, you have to have over 30% attendance. Elections will be taking place the following Friday, but attendance is going to be locked after tomorrow night. To run in the election, you have to have over 50% attendance. And to vote, again, 30% attendance. After that, April 18th is the deadline to declare your candidacy. So that's going to be Sunday at midnight of this weekend. If you want to declare candidacy to run, you have to do it by midnight. And then I'll go over this a bit more tomorrow. I'll send out a big announcement in the announcements channel. So if you're interested in running, keep your eyes out for that. Then next week is going to be campaigning. And you can listen or talk to any of the potential candidates that you want to run for eBoard. And finally, April 23rd through 24th is going to be voting. Voting is going to be anonymous. And then the 27th, results will be announced. And the transfer of power happens at the end of the semester, after school ends. So for those of you interested in the election, that's what's going on. Okay. What the heck does James doesn't like skinny people confirmed supposed to mean? What?
You read it right. You said you're only ordering larges. What about all my small people out there?
Wait, what?
Wait, James and June, when you have time this week, could you send me the materials about the shirts and ordering? I know we're gonna have a meeting on Tuesday, but I just want to contact the essay ahead.
Josh, I'm going to be completely honest with you. I have no idea how this works. And that's why I'm letting you handle it. Tony might know a bit about it.
Yeah, I'm going to manage it, but I just want to have the shirts.
Yeah, the shirts, the actual shirts and the website. Yeah, we'll hand that all off to you. So
yeah, so send it to my email or
okay,
Discord.
yeah. I'll email it to you, or we will DM it to you. So I know you don't see it when we normally
Yeah,
miss.
so I'll contact the SA and then handle it.
Okay. Thank you, Josh. All right. And
Yep.
look in the Treasurer's Handbook, because they have a big section on that on how to make a PR request. And that's pinned in either the officers chat or the e-board chat. And I can send that to you as well. Anyway.
I mean, if
with
you
that,
pin it, to be honest, I don't know how to use a Discord, so...
Okay, we'll send you a copy. All right. So
Yeah,
with that, thank you everyone for coming out tonight. Good luck in elections. If you want to check your attendance beforehand, I think Tony is accepting requests to message people with their attendance. We're going to be posting the attendance and making it public for everyone who's over 30% attendance. So, and we're also going to be ranking that just to show everyone where everyone's attendance is at. So if you are interested, by all means, reach out to Tony. It's a bit late now to try and boost your attendance. The best you can really do is go to the workshop tomorrow or the event tomorrow and stay at it for the whole thing. But yeah, so good luck to everyone. Have a nice night. Bye-bye.
Good night, everyone. Thank you for coming.